So we'll start with a discussion of the pop quiz. This was the weekly pop quiz MCQs in this pop quiz. The weekly pop quiz 11. If you have question or a doubt, you can mention. Any doubt in question 1? Question 2. This was a weekly pop quiz 11. Question 3. Question 3. Okay. So in question 3, ammonium nitrate can decompose explosively when heated. What are the changes in oxidation number for two nitrogen atoms in ammonium nitrate when this reaction proceeds? So the ammonium nitrate, what it contained ammonium ion, which is a charge +1, and the nitrate ion, which is a charge negative. So what is the net charge on what is the charge of nitrogen in ammonium ion? Each hydrogen is +1, so there will be 4 hydrogen, it will be +4. So what should be the charge on the nitrogen? So it should be -3. So in ammonium ion, the nitrogen is -3 because the net charge on the ammonium ion is +1. Same way, what is the net charge on nitrate ion? It is -1, -1. So each oxygen is -2, so 3 oxygen will be -6. Because we want a net charge to be -1, so what should be the charge on the nitrogen? So the charge on the nitrogen should be +5. So here the nitrogen is -3 and here the nitrogen is +5. But when it form a compound, which is N2O, what is the oxidation number? Each oxygen is -2 here. So this, because overall it's a compound, so it means this should be +2. So if 2 are +2, each N is +1. Now, what are the changes in oxidation number for the two nitrogen atoms? What are the changes in oxidation number? It was -3 become +1. So if -3 become +1, by how many numbers it has increased? So it has increased by 4. So this is increased by 4. And this is +5 become +1. So how many numbers it has decreased? So it has decreased by 4. So one of them is increased by 4. Another one has decreased by 4. That's why option D is a valid answer for this question. Question 4, any doubt? Question 5. Any question or doubt? Question 5. Question 5. Okay. In question 5, 2.92 grams of a group 2 metal react with an excess of a chlorine to form 5.287 grams of a compound, which formula is XCl2. What is metal X? So how will identify this metal X? The group 2 element is reacting with the chlorine to form a compound XCl2. So we have 2.92 grams of this compound, this element, and it, as a result, what it is forming 5.287 grams of the compound which contain chlorine. Now, as you can see, the balance equation, the ratio between the metal and the compound is 1:1. Like if 1 mole of that group 2 metal is reacting with the chlorine, it will form 1 mole of this compound. So what we will do, we'll find the moles of the element and we'll find the moles of a compound. If the ratio of the, like if we get the same ratio, like same number of moles, so it means the ratio will be 1:1. Like if we start with barium. So what is the mass of a barium? So when we check the periodic table, in the periodic table, you will get the mass of a barium. So that is, so this is a barium which is 137. So barium is 137. Barium is 137 when you check the periodic table. That is, this is beryllium. It is barium is written, so it is 137. So when you check, you divide by to get the moles equal mass in gram, divide by molar mass. So means if you divide it by 137, 2.92 divided by 137, what's the answer for this? 2.92 divided by 137, what's the answer? So we got 0.02 moles. So this is 0.02 mole. Now this we have to divide it by molar mass. Like if this element was barium, so what is the total mass? Chlorine, one chlorine is 35.5 and there are two of them. So this will be 71 and plus 137. So 71 plus 137 and the final answer 5.287 divided by the molar mass. We get the moles of this compound. What's the answer? The final answer, I'm talking about the moles. So 137 plus 71, that is 208 is a total mass. So 0.025. So the ratio, because if barium was the answer, what should be the ratio? The ratio should be 1:1. Like, because if a any group 2 metal is reacting with a chlorine, the ratio of the compound to metal should be 1:1. So is it 1:1? No, it's not 1:1. Like we don't get the same number of moles. For this one, we got like 0.02 moles, and the other one, it was 5.287 divided by 208. So we got 0.024 moles. No, no, we don't take almost. It's like we should get the same number because the other was, when we check the other one, it was 2.920 because the ratio should be 1:1. Divide by 137. So it was 0.21. If you see the number difference, this is 0.21 and this is 0.25. So there is a difference between them. So it means the ratio, it's not a barium. If the difference was there, then it should be a very small, but 0.21 and 0.25 are not 0.025. It's not same as 0.021. That's why means it cannot be the first option. Then we check with the second option. So only thing what we have to do, we have to just change the element here. If the element was calcium, so calcium is there. If the second option we select, if calcium was there, then this will be divided by 40 and this will be added 40. So 2.920 divided by 40, that is, so the final answer will be 0.073. And same way, 5.287 divided by this 71 plus 40, so 111. So if this answer 5.287 divided by 111, how many moles we get? So we got 0.047. So again, the mole ratio is not same. This is 0.07, this is 0.04. So means it is not calcium. Then we check what if the element was magnesium. If it was a magnesium, then we'll divide this by 24 and here 24 will be added. So if we divide, we got 0.12. And what is the answer here for the moles of the compound? 0.056. So this was 2.920 divided by 24, which was 0.1216. And when you divide 5.287 divided by the total sum, you got 0.030. So 0.030, because the total, this will be 71 plus 24, which is 95. So the 5.287 divided by 95, that will make, no, that is not 0.0, this will be 0.055. Because this is 24. So 24 plus 71, that will be 95. If this total is divided by 95, we got 0.055. So again, you can see it's not same. So means it cannot be magnesium. Then we check with the last one. The last element, that is strontium. So what is the mass of a strontium? When you check the periodic table, it is 88. So the moles of the strontium, how many moles of strontium are there? So you got 0.033. So 0.033. And here when you add 88, 5.287 divided by 71 plus 88. So we got approximately 0.00, it is 5.287, because that is 71 plus 88. The sum is 159. So 5.287 divided by 159. So you got 0.033. So we got approximately same. So it means the ratio is 1:1. So what is this element? This element should be strontium. So what you have to do for this question, first you have to write a balance equation for group 2 metals when it react with the chlorine, and then just work out the moles of the element and the moles of the compound. Because the mole ratio according to equation, it should be 1:1. That's so the when we work out the from the mass, when we work out the moles, we should also get the ratio 1:1. Is it clear, this one? And there was a doubt in question 1 and 2, as one of the student asked. The question is, given the following enthalpy changes, what is the standard enthalpy change of formation of iodine trichloride? So we want a formation. The term formation means when element in their standard state form a compound, we call formation. So here, iodine, what is the state of iodine at room temperature? Iodine is solid at room temperature, and chlorine is a gas. And we want the formation of ICl3. The equation must be balanced. So if it is 3 and we put 2, so the equation is balanced. This is the unknown. This is what we need, because iodine, the formation means when element in their standard state form a compound, we call that as a formation. That is what we need. But what we have with iodine gas reacted with chlorine gas, it will form ICl3. So when iodine gas, iodine vapors, and reacted with chlorine vapors, this will form ICl3. This energy is given minus 214, 214. And when iodine solid is converted into iodine gas, this energy is given 38. So we work out the Hess law that overall energy change is independent of the route or the path we follow. Where the two arrows are pointing out, that is always the start of the cycle. Where the two arrows are pointing in, that is end of the cycle. So if we follow route 1 or we follow route 2, the overall energy change is independent of the route or the path we follow. So it means the path 1, the energy of a path 1, which is x, is equals to energy of the second part, which is plus 38 and minus 214. So what is the value of x? Minus 214 plus 38. So we get negative 196. Now, this negative 196, as you can see, it's the energy change for 2 moles when 2 moles of ICl3 are there. But in the question, what is the standard enthalpy change of formation? So whenever standard enthalpy change of formation, they ask, we need for 1 mole. If 2 moles of ICl3 are formed, the energy change is minus 196. So for 1 mole, what we do? Minus 196 divided by 2. Because we need for 1 mole. 176, okay. Say 176. So this is 176. So 176 divided by 2. Why 176 divided by 2? Why this 170, not 196, 176? 176 divided by 2. Why? Because the question is standard enthalpy change of formation of iodine trichloride. Means standard enthalpy change is always for 1 mole. Like for 1 mole, how much energy? Here, when we use this cycle, we got this energy, but this energy is for 2 moles of ICl3. If we need for 1 mole, so 176 divided by 2. So what we get? We get 1 minus 88, or B will be the right answer. Is it clear, this one? So because the question was for 1 mole, that's why we have to divide. If let's say if it was 5 moles written here, then we'll divide the final answer by 5. Because standard enthalpy change is always energy for single mole, 1 mole. In question 2, what is the order of enthalpy change from most negative to most positive? First thing, positive, it's a bond breaking is a endothermic and bond forming is exothermic. So this is a bond breaking, so this will be endothermic. This is a bond forming, chlorine atoms are forming a bond here. This is also bond forming, and this is bond breaking. So 2 of the reactions are bond breaking, 2 of the reactions are bond forming. Now we want from most negative, like which we release the most energy. So here chlorine-chlorine bond is formed. The chlorine-chlorine bond forming is 340. And here CH3Cl bond is formed, like carbon-chlorine bond is formed. So chlorine-chlorine bond energy was 244 and carbon-chlorine bond energy is 340. So which will be the most or give out the greater amount? So this is 244, this is 340. So which will give out more? So means this will be more exothermic, more negative. Because that is 340 or it's an exothermic, so minus 340. And this one chlorine, minus 244. So the most negative will be R. Anything which is starting with R. So even we don't have to check other C is starting with R. So this will be R. Then we will have Q, which is minus 244. Then we have here bond breaking for bromine. So it will be 193. And the bond breaking for carbon and hydrogen, it is 410. So 410 will be at the last. Is it clear? How we worked out? So what we did, we work out the bond. First, we work out the type of a reaction. How we work out the type of reaction? This is a bond breaking. Bond breaking is endothermic. This is bond forming, like chlorine atom form a chlorine molecule. So this is a bond forming, so it will be exo. This is also bond forming, so it is exo. And this one is a bond breaking, so bond breaking is endo. And the energies are given here, bromine bond breaking. So if it is a bond breaking, it will be positive 193. Then we have chlorine bond forming. So chlorine, that is 244, but we'll write minus 244. And this one, carbon and chlorine. So carbon and chlorine, we'll write minus 340. And when CH is there, carbon hydrogen bond breaking. So carbon hydrogen bond breaking is 410. So what is the order? We need from most negative to most positive. So which is the most negative? R is the most negative. Then followed by Q. Then followed by P, which is 193, and followed by S. So C will be the right answer. Question 6, any doubt? 6, 7, 8. Question 6, 7, or 8. Question 9, any doubt? 9, 10. Question 10. A Haber process, just remember the manufacture of ammonia by a Haber process. When nitrogen react with a hydrogen, it gives off ammonia. And the forward reaction is exothermic. And we use iron as a catalyst. We use around 450 degrees for a reaction. And we use a high pressure, about 2 to 300,000 Pascal, or 10 kilopascal, or 200,000 Pascal. 200 or 300 atm, you can also say, rather than Pascal. The percentage of ammonia obtainable if equilibrium is established, which diagram correctly represent the two graphs? First, what will happen? Because the reaction is exothermic. So if we increase the temperature, the yield will decrease. The equilibrium for exothermic reactions, if we increase the temperature, the yield will decrease. So we'll have a lower yield at a high temperature, and we'll have a higher yield at low temperature, because exothermic reactions, whenever a chemical reversible reaction is exothermic, when you increase the temperature, equilibrium will shift towards the left, or the percentage of the product or the yield will decrease. And if you increase the temperature, if you decrease the temperature, the percentage of a product will increase, because the equilibrium will shift towards the right hand side. Here the equilibrium will shift towards the left hand side. So first thing, at low temperature we'll get a higher yield, and high temperature we'll get a lower yield. And then what is the effect of the pressure? As we, on x-axis we have a pressure. So if we increase the pressure, equilibrium will shift towards side of less moles. So here we have 1 mole and 3, so total 4 moles and 2 moles. So if we increase the pressure, equilibrium will shift towards side of less moles, so it will shift on the right hand side. Like we'll get more ammonia. So first thing, why C and D are wrong? Because when we are increasing a pressure, the yield is decreasing. So either A can be an answer or B can be an answer. As for reversible reaction, if you increase the pressure, equilibrium will shift towards side for the less moles of a gas. And in this case, we have less moles on the product side. So equilibrium will shift towards the right hand side, or we will get more ammonia. And the reaction is exothermic. So if exothermic reaction give higher yield, a greater amount at low temperature, so we have two options, A or B. But why A we select? Because if the temperature is low, we get a higher yield. If a temperature is high, we get a lower yield. Is it clear? Question 10. Question 11, 12, 13. Any doubt? Question 11, 12, 13. Question 14, 15. Any doubt? Question 16, 17, 18, 19. Question 18. In question 18, we need which silver halide will take the shortest time. Remember, the carbon iodine bond will break much faster as compared to carbon bromine bond, and a carbon bromine bond will break much faster than carbon chlorine bond. So this will be the fastest and this will be the slowest. So we check the options. So it cannot be these two because the carbon chlorine bond is there. So either A can be an answer or C can be an answer. But which one will react faster? The tertiary halides will react much faster as compared to secondary. So if you have a high tertiary halides, they will react much faster as compared to that of secondary, and the secondary will react much faster as compared to that of primary. Because the carbon cation which will be formed is more stable, so it can easily break the bond. So this is the order for a tertiary will react faster than secondary and secondary react faster than primary. So first thing we select which carbon chlorine or carbon iodine. So it should be carbon iodine. And then we check which is the primary and which is the secondary or tertiary. So which is the secondary here, which is the tertiary here? You can see the first one is a tertiary halogenoalkane. So that's why A will be the right answer. So A will take the shortest time to react. So because the carbon iodine bond is weaker as compared to carbon chlorine bond, so it can easily break down. And then the type of the halogenoalkane, if it is a tertiary, as it break down, it will produce a more stable carbon cation. That's why it will break down easily. Question 19, 20, any doubt? 21, 22. That's the last one, 22. Any other doubt in this? The MCQs Pop Quiz 11.